Imagine a future where energy is abundant, clean, and virtually limitless. No fossil fuels, no harmful emissions, just pure, sustainable power that can fuel our world for millions of years. Sounds like science fiction, right? Well, China's artificial sun just took us one step closer to making that future a reality. China's experimental advanced superconducting Tokamak, or EAST, has achieved something truly groundbreaking. It managed to sustain high confinement plasma operation for 1066 seconds, a world record that is pushing the boundaries of fusion power research. But what does this mean for us? And why is this achievement such a big deal? Let's dive deep into how this artificial sun works, why fusion energy is considered the holy grail of clean power, and what this breakthrough means for the future of energy on Earth, and possibly beyond. What is the artificial sun? First, let's clear up a common misunderstanding. EAST isn't literally an artificial sun in the sky. It's a type of fusion reactor, designed to replicate the process that powers the actual sun, nuclear fusion. Nuclear fusion happens when two light atomic nuclei, like hydrogen, merge to form a heavier nucleus, releasing an enormous amount of energy in the process. This is the exact same reaction happening inside the sun, where extreme pressure and temperatures cause hydrogen atoms to fuse, producing the heat and light that sustain life on Earth. But here's the challenge. Recreating this process on Earth is insanely difficult. The temperatures inside a fusion reactor must exceed 100 million degrees Celsius, several times hotter than the sun's core. And maintaining this ultra-hot plasma in a stable state for a long duration has been one of the biggest challenges in fusion energy research. That's where EAST comes in. Located in Hefei, China, EAST is a tokamak, a special kind of experimental fusion device that uses powerful magnetic fields to confine the superheated plasma and keep it from touching the reactor walls. Breaking records. What makes 1066 seconds special? On Monday, EAST achieved what no other fusion reactor in the world has ever done. It maintained a steady high confinement plasma operation for 1066 seconds, almost 18 minutes. To put this into perspective, the previous world record, also set by EAST in 2023, was 403 seconds, less than 7 minutes. In just 1 year, scientists have more than doubled the record. This milestone brings us closer to sustaining fusion reactions long enough to generate usable electricity. The fact that EAST achieved this without losing stability is an enormous breakthrough. It shows that we are inching closer to self-sustaining nuclear fusion, which is the ultimate goal. Why is fusion energy so important? You might be wondering, why are scientists spending decades and billions of dollars on nuclear fusion research? The answer is simple. Fusion energy has the potential to change everything. Number 1. Unlimited energy. Unlike fossil fuels, which are limited and damaging to the environment, fusion fuel is virtually limitless. The main fuel for fusion reactors is hydrogen isotopes, found in water and lithium. Just a few liters of seawater could provide as much energy as tons of coal. Number 2. No greenhouse gases. Fusion doesn't produce carbon dioxide or any other greenhouse gases, making it 100% clean energy. If we can master this technology, it could completely replace fossil fuels and solve climate change. Number 3. No risk of meltdowns. Unlike nuclear fission, which powers current nuclear reactors, fusion is much safer. There's no risk of catastrophic meltdowns like Chernobyl or Fukushima because if something goes wrong, the reaction simply stops instead of spiraling out of control. Number 4. Minimal radioactive waste. One of the biggest concerns with traditional nuclear power is radioactive waste, which remains dangerous for thousands of years. Fusion reactors produce far less waste, and it's much easier to manage. Simply put, fusion energy is the dream, and EAST's latest breakthrough takes us closer to making that dream a reality. How did China achieve this? So, how did EAST break the world record? The answer lies in cutting-edge advancements in heating and magnetic confinement technology. According to Gong Shanzhu, head of the EAST Physics and Experimental Operations Division, several major upgrades were made since the last round of experiments. The heating system was doubled in power while maintaining stability. Previously, it operated at the equivalent power of 70,000 household microwave ovens. Now, it's even more powerful. The magnetic confinement system was further improved, allowing the plasma to remain stable for a longer duration. The plasma control software was fine-tuned, enabling more precise regulation of temperature and pressure. These improvements have brought us closer to achieving continuous and stable fusion reactions, which is crucial for developing practical fusion power plants in the future. The bigger picture. East, ITER, and the future of fusion energy. China isn't working alone in the quest for fusion energy. In fact, East is part of a global effort involving some of the world's biggest scientific collaborations. One of the most ambitious fusion projects is ITER, International Thermonuclear Experimental Reactor, currently under construction in France. ITER is set to become the world's largest fusion reactor and is expected to demonstrate large-scale energy production using nuclear fusion. China officially joined ITER in 2006 as the seventh member and is responsible for 9% of its construction and operation. East serves as a testing ground for many of the technologies and techniques that will be used in ITER. Meanwhile, China is also developing its own next-generation fusion reactor, called the China Fusion Engineering Test Reactor, CFETR. This reactor is expected to be a stepping stone towards building a commercial fusion power plant by the 2050s. What's next? While East's record-breaking experiment is an incredible milestone, we are still a few decades away from commercial fusion power. Scientists still need to solve key challenges, including scaling up fusion reactors to produce more energy than they consume, called net energy gain, maintaining stability for hours, days, or even years instead of just minutes, developing materials that can withstand the extreme conditions inside a fusion reactor. However, progress is happening faster than ever. With East's latest achievement, along with ongoing research worldwide, many experts believe we could see the first working fusion power plants by the mid-21st century. Imagine a world where electricity is clean, limitless, and virtually free. No more energy shortages, no more reliance on oil and gas. Just pure, sustainable power for everyone. That's the promise of fusion energy, and thanks to breakthroughs like this, we're getting closer to making it a reality. The global race for fusion energy. China's East is just one of many groundbreaking fusion projects around the world. Countries like the United States, the United Kingdom, Japan, and South Korea are also investing heavily in fusion energy research. Private companies, including startups like Helion Energy and Commonwealth Fusion Systems, are racing to develop commercial fusion reactors. The competition is fierce, but it's also driving innovation at an unprecedented pace. Governments and investors are pouring billions into fusion technology, hoping to be the first to crack the code for limitless clean energy. The more players involved, the faster breakthroughs will come, and the sooner we can transition to a world powered by fusion. The challenges that remain. Despite the massive progress, fusion energy still has some major hurdles to overcome before it becomes a practical power source. One of the biggest challenges is achieving net energy gain, where a fusion reactor produces more energy than it consumes. So far, experiments like East and ITER have demonstrated the ability to sustain fusion reactions, but they still require more energy input than they generate. Another issue is building materials that can withstand the extreme temperatures and radiation inside a fusion reactor. Scientists are working on new high-temperature superconductors and advanced shielding materials to address these challenges. Once these obstacles are overcome, fusion energy could completely transform the global energy landscape. A future powered by the stars. If fusion power becomes a reality, it will revolutionize industries and change life as we know it. Imagine cities running on clean energy without pollution, space missions powered by fusion reactors, and entire countries no longer dependent on fossil fuels. Fusion energy could even enable deep space exploration, providing the power needed for long-term missions to Mars and beyond. While there's still a long road ahead, every milestone, like East's latest achievement, brings us one step closer to unlocking the limitless power of the stars. The dream of a fusion-powered future is no longer just a fantasy, it's a goal within reach. So, what do you think? Will fusion power be the energy source of the future? Let us know in the comments below. And if you enjoyed this video, don't forget to like, share, and subscribe for more fascinating stories about the future of science and technology. Did you enjoy this video? Check out other clips of Amazing 7 and be sure to subscribe and ring the bell to be notified our latest videos.